All right, let's go ahead and begin while it's loading up. Last time we went through the first few parts of chapter 3. We learned about the conditional statements. We learned about converting statements into symbols. Give me an example of a conditional statement, or what is a conditional element? Or conjunction. Give me an example of a conjunction. Exactly, and. So we have a conjunction, which is the and statement. What symbol do we use to represent and? What symbol did we use in chapter 2? And. We talked about intersections and unions. The other one's called a disjunction. That's an or statement. What's its symbol? In chapter 2, when we deal, it's like that. So in this chapter, in chapter 3, we deal with statements. What did we deal with in chapter 2? Starts with the letter S, ends with X. Sets. Yeah, sets, subsets, proper subsets. Because here you compared two sets. Here we compare two statements. What's a statement? What's an example of a statement? Because the condition for a statement is you have to be able to prove it as true or false. In other words, no exclamations, no opinions. It has to be just a true or false statement. All right. Well, let's look at the negations. The negation of the and statement in chapter 3 and in chapter 2. How do we show negation of a statement? No, it's a symbolic. It says there's no basic. It's just what's the symbolic representation for negating a statement? The tilde. In chapter 2, how do we prove the negation of a set? Line above. Very good. what does it mean conditional statement? Give me an example of a conditional statement. It's an if-then statement. There has to be a condition. If you do this, then you can do that. What symbol do we use it in chapter 3 to represent a conditional statement? If P, then Q. What's the representation? What's symbolic representation for that? I'm gonna have to start having quizzes in the morning. I need you guys to look over your notes every now and then. Because remember, at the beginning of the semester, I said that all our exams are going to be online. I could easily revoke that and say all our exams are going to be in class or in the testing center. I need you guys to learn this stuff. The way you do your other classes, it's no different. What's a quantifier? So put your phones away. I don't see anybody has cell phones out because I want answers instead of you guys surfing the web or answering your emails. So if you guys were participating, then I might think twice about it, but put your phones away. Get them off your desks, put them away. So what's a quantifier? Okay, what do you think quantify means? When you quantify something. Mm-mm. Mm-mm. Quanti. Can you think of another word that sounds like that? Quantity, quantify. So what does a quantity mean? How many? Yeah, you're putting a number on something. That's what this is. Quantifiers are you're putting numbers, not actual numbers, but theoretical numbers. Example. All. What's another quantifier? Some or none. These are the most common quantifiers. They're all subsets, at least one, at most. So you have inequalities now. All A are B. Is that a quantified statement? Yes. Graphically, it looks like this. All A are B. What's the negation of it? Here's the statement. What's the negation of it? Mm-mm. All A are not. Logically, you think that if the opposite of all is nothing, no, because all you have to do is find one example that there's not all of them. An example would be this. The negation is some A are not B. That's the negation. Because what this does to negate it and make it useless, you have to find at least one way it's wrong. That's called a counter positive. Okay. How about some A are B? What's the negation of that? Because what this one looks like is some A are B. What's the negation of it? Mm-hmm. Okay, now instead of saying all A are not B, what we can say is this. No A are B. No A or B, so they have no overlapping. All right. That sounds confusing, but to prove that this is not a true statement, all you have to do is have one element in A that's not in B. Then that statement's wrong, because not all of them are true. In order to prove this wrong, you have to prove that there's nothing in common. So let me put it in a way that makes it easier to memorize. Statement, negation. All A are B, and the opposite of that is no A are B. This is not the negation, it's just the opposite. Some A are B, some A are not B. The easiest way to memorize it is this way, because here you have the positive ones, here you have the negative ones. These are opposites. That's the negations of them. These are negations. So the opposite of all is some, are not. The opposite of some are is that none are. So all and no, some are, some aren't, and just cross them. And that those are the negations of the statements. Example. All humans are mortal. What's the negation of that? Some humans are not mortal, right? So yeah, once you memorize this, it makes it a lot easier. So we talked about the and statement. We talked about the or statement, the if then statement. The biconditional statement. We're also going to look at the inverse and converse of a statement. We're going to do that next. So again, the symbol for and is that one. The symbol for or is that one. The symbol for if then. So how would you read that statement? No, so simply if P, then Q.
Right, if P is correct, then I'm not saying it. Then I'm trying to say something like that.
No, don't put any true and false in it just yet, because don't do that just yet. Remember, we did the true and false tables for these last time. And we're going to do a lot more of those today. A lot more true and false tables. The symbol for biconditional. Now, let me show you why that one's called a biconditional. What do you think biconditional stands for? What do you think biconditional means? Yeah, but two conditions. What do you think the two conditions are? If P, then Q, and then if Q, then P. That's how come a biconditional looks like this. If P, then Q goes that way. If Q, then P goes this way. We use that symbol in chemistry. If you've ever taken a chemistry class, a subject called stoichiometry is when you talk about balancing equations. One oxygen plus two hydrogens is H2O, water. Or I could go the other way. I could break apart this symbol, the water. If I do that, I get oxygen and I get hydrogen. The way chemists do it is this way, but it's exactly the same thing. Okay, now in a conditional statement, the leading part is called the antecedent. That's the initial statement. That has to be the condition that has to be approved first. Because if this works, then we can go here. This is called the consequent. So it goes antecedent implies a consequent. or an action implies a consequence. You ever hear that? An action implies a consequence. For every action, there's a reaction. Is consequent, yeah. For action implies a consequence. Now, how would you read this statement? How would you read this statement? P, because going this way is an if statement. So P, if and only if Q. That's a biconditional statement. Whenever you see if and only if, that means it has to go both directions to be true. An abbreviation for this is IFF. Trying to look for some examples here. Yeah. You'll pass the course if and only if you pass all the homework and tests. Okay, here's the operation. The symbol and the meaning. So we have negation. We're going to summarize a lot of the stuff we've done so far. So negation, what does negation look like? That means negation. How would you read that? So if we had a truth table, if P was true and false, what would not P be? What would be this one? False. And this one would be true. Yeah, so it's just the opposite truth symbol. Yes.
You go down right there. Is that the symbol for biconditional?
Yeah, that's biconditional. Another way of saying it, whenever you see if and only if, that means biconditional. Yeah. Because we have two conditions. In order to prove this, you have to prove that if P then Q, and then you have to prove if Q then P. And they have to have the same answers. If we do a truth table, they have to have the same truth table. Conjunction. What symbol do we use for conjunction? What symbol? Yes. Arrow up, right. So how would you read that? Mm-hmm. Very good. Yeah, I mean, I see a lot of you outside. it's sometimes just that easy. It's just what it says. A disjunction. What's the disjunction going to look like? Wrong direction. Yeah, it's the V. We had that one there. So it's the arrow down. And you read that how? P or Q. Conditional. And you read that how? Very good. If P, then Q. I mean, there are many ways you can say it also. You can say if P, comma, Q. So if this is true, then this happens. You don't have to put then all the time. Or you could put example of this one. You can go outside if you did your homework. If you did your homework, then you can go outside. So again, you have to look for that combination, that there has to be a initial condition that has to be satisfied before you can do something else. A biconditional. You're right. It's the arrow of both sides. How would you read that?
If and only if.
Q. P if and only if Q. What if I gave you this statement? Yeah, it's red. But well, you can't, because what's missing from this? Where do you start? Yeah, well, yeah, in other words, there are a hierarchy of what's more important. Is the and statement more important, or is the if then statement more important? And we'll go through the rules in a second, because we know that if we had parentheses, we can do that. Are they the same? How would you tell me if they're the same? Because there's no way you can read it the same. Because this one, You have to say, if if Q and not P, then not R. This one says if Q and Q and if not P, then not R. But again, it's the parentheses. The only way you can prove if they're the same or not is by doing a truth table on them. You guys want to do some truth tables? Okay. Let's do two different sets. We'll do this one, and we'll compare their answers. How many rows are we going to need? We're doing this one first. How many letters are there? There's P, Q, R. 3 letters. So 2 to the power of 3 equals 8. So we're going to have 8 rows. One, 2, 3, 4, 6, 7. We may have to go further. Remember, we're doing this side first. So we have the letters Q, P, and R. Remember last time I told you how to do this when you have more than 2 letters? Always start from inside and work your way out. So we have to do these 4 first. So it's true, false, true, 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 false, false, true, false, false. Then we have to do the bottom 4. True, 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 false, false, true, false, false. Now, all of these top 4 are if Q is true. And the bottom 4 if Q is false. So far, so good? Because we're working backwards. We create one of these small boxes for all the trues. Then we create other boxes for all the false. So what do we do first? What are we trying to find? We have to do inside the parentheses first. We have a Q. Do we have a not P? No, we have to build a not P. You have to build what you don't have. So P is true, not true would be false. Not true would be false. Not false is true. Not false is true. Not true is false. False, true, true. So now I have both elements of this. So now I build that parenthesis. I use the Q column and the not P. What symbol is this? And. So if I have true and false, what's that going to be? Think of what we did last time. What picture do we use? It's an and.
True or false thing.
It has to, yeah. That's all we're doing here with true and false. Nothing else in this. Why? Why would it be false?
Remember, I was like, if it's true, it falls and closes. So-
Right, on one pipe. Very good, yes. So if the first one's open, the second one's closed, nothing comes out. The first one's open, second one's closed, nothing comes out. If they're both open, something comes out. They're both open, they're both closed, they're both closed. As long as if one of them's closed, it's not going to work. Okay, what's the next thing we have to build? So we have, this is the parenthesis part. We've got the parenthesis part. What else do we need? We have to find the not R. Because we can't do the if then because we don't have a not R yet. So we'll go to R. Opposite of true is false. Opposite of false is true. False, true. False, true. False, true. So it's the opposite of the R column. Do we have all the pieces of this puzzle? We have the Q and not P. That's this column. And we have the not R. That's this column. Now we could do a conditional if then. What picture do we use for the if then statement? For that statement.
Go inside.
So it's only bad is if you go from high to low. It's okay if you keep the same amount. If it's on top, it's top, or bottom, it's good. You're not losing any money. It's only bad when you go from high to low. So it's only bad when you go from true to false. That's the only time it's bad.
What is the number again?
What's that?
And R.
In this one, not R? It's not, and it's a tilde, it's not R.
Oh,
It means the opposite of R. R is this column, so I take the opposite symbols. It's the squiggle line, tilde. All right, so if false, then false. Are we losing ground? No, so it's true. If false, then true.
no.
True. If true, then false. True, then true. False and false. False and true. False and false. False and true. So we only have 2 times this thing fails. So that's this first statement. Now let's do the other one. we're gonna try to do this statement, Q and not P, not R. So we have Q, P, R. Since we have three of them, we start, we have to have 2 by 4. True, 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 false, false, true, false, false. True, 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 false, false, true, false, false. The top 4 are true. The bottom 4 are false. Okay, what's the next thing you have to build? Let's look at this equation. Do we have Q? Yeah, right here. Do we have not P? Nope. So we have to create a not P. So we go to the P column and the opposite. So it's false, false, true, true, false, false, true, true. Okay, we have Q, we have not P. Do we have not R? No, we have to build the not R. False, true, false, true, false, true, false, true. So what do we do first? Nope, you have to do the parentheses first. So we have, because it has parentheses, that tells us that that's more important. We do that first. So we look at if not P, then not R. Not P, not R. False and false. True. False and true. True. True, false. False. True, true. False, false. False, true. True, false. True, true. Again, we only lose money is if we're going from high to low. So that's our parenthesis. Now we do the entire equation. Q and not P, then not R. So we're looking at this column and this column with an and statement. And the only time it's true is if they're both open, if they're both true. True, 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 false, true, 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 false, true, false, 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 true, false. Yeah, of course, yeah, you're fast. Are they equal? Are the two statements equal? No, this is TTF. This one's TTF. TTF, TFF. So this is where they miss it. As long as there's one element that's different, they're not equal statements. So that's how you compare two statements to see if they're equal or not. Or two conditional statements. But that's not what we're looking at. We're looking at what's more important. Is there a hierarchy of how you do things? Yes, there is. In math, in algebra, we have the order of operations. We have in math, we have the order of operations. You do special operations first. Brackets, squiggly brackets, parentheses, exponents, radicals, absolute values, and all sorts of stuff. There are over 400 of them. And we'll look at those when we do the math part. Then we look at multiplication and division. Because they're on the same level of importance, one's not more important than the other. They're both equal in importance. Then we do addition, subtraction. When dealing with sets, the order of operations with sets, we're going to go from low to the highest. Actually, no, we'll do it like we did here, the most important. So the most important thing are biconditional statements. All right, everybody, have a good weekend. Bye.
That's the most important.
That's the most important because it has to do with both of them. You have two statements in one, so that's the most important. You do that first. Then you do conditionals. Then you do conjunction. Oop, that's not an A. And disjunction. They're both the same level of importance. Then you do negation. Yeah, so that's the level of importance. That's the order of operations. If there are no parentheses in the statement, so if I gave you this, what would you have to do first? Top down. Are there any biconditionals? No. Are there any conditionals? Yes. So we have to do this. We have to do this to this. So that's where the parenthesis goes. You put parentheses around what you have to do first. So in order to do this, you now have to find you work inside the parentheses. You know that's there. Are there any other conditionals? Are there any conjunctions or disjunctions? Are there any negations? So you have to do those next. And then you can do the operation. This is all the same as mathematics. This is where mathematics got its rules from. That's why I have to do what's inside the parentheses first and read left to right. So this is the correct answer or the correct statement. Which means that second one we did is the accurate one. So the second one is the accurate one. So if you're given a statement with no parentheses, the order of operations is this when it comes to sets. Any questions so far? Let me see here. So here, you're gonna tell me where to put the parentheses. So the statement of the first one. Where would you put the parentheses? What kind of statement is that? Conditional. Now, what would you do first? It's also a conditional. Oop. Right, because the biconditional is more important. This is a biconditional. Ooh. Mhm. Since they're both in the same level of importance, you go left to right. That's an and statement. Right, so if there's nothing there, then you have to say, what do I do first? You begin with, if they're both the same level of importance, you do those. Oh, are we finished writing this stuff? Now let's look at negations. We've talked about negations of quantifiers, quantified statements. What about when we have statements like this? Or statements like this? The negation of a conditional statement. The negation of a conditional statement, when you have this, it equals to that. I did when we do something like this, it means it's very important. This has to be true. It equals it, no matter what it equals. Let's test it. How do we test it? Truth statements. We're going to do these in a minute. Those are a lot easier. Again, it's the same. This is where we got rules in our math. So let's look at this statement. Do they equal each other? How many rows do we need? 4, because we have 2 elements, P and Q. So 2 to the power 2 is 4. We need 4 rows. So there's P, there's Q. Let's start with that. True, 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 false, false, true, false, false. So what's the first thing we have to do to prove this, to fill out this truth table? We're only doing this side first. Inside, very good. Inside the parentheses, we have to do if P, then Q. We have to do the parentheses first. If true, then true. True, then false. False, then true. False and false. Only if it goes down. So we have the parentheses. Now we have to do the whole statement. That means we negate that previous column. So it's false, true, false, false. Now we have to do this side. P, Q. Such. True, true. True, false. False, true. False, false. That's just setting up our truth table. What do we have to build first? We can't do P and Q because that's not Q. What is it? Do we have not Q anywhere? No, so we have to build the not Q. So since Q is true, not Q is false. False to true, true to false, false to true. Now we can do the statement with P with these two columns. With the and statement. True and false. False. True and true. False and false. False and true. Remember, and is a single pipe, ladies and gentlemen. So are they equal? Yes, these are equal, so they are. It's an absolute equality. Any questions so far? You have to learn how to look at piece by piece by piece. What would you need to build the next part? I heard somebody else say, well, we do the P and statement. No, you can't. You can't do the P and because this side is not defined. So you have to find the not Q first, and then we can do the whole statement. It's easier if you write them down when you're going, because write them down, it's going to help you memorize them. The other two that we had were P and Q. Yeah. P and Q. We're going to look at the negation of P and Q. Then we're going to look at P or Q and the negation of P or Q. So let's look at the negation. What this, the negation, what it does, it negates everything inside there. So I take this symbol and I put it to every element inside the parentheses. So let's do that one first. P and Q. So it's not P, not N, not Q. Okay, not P is just not P. What is not and? What's the opposite of and? Or. So there's the answer. The negation of an and statement is a negation of P and Q with an or in the middle. Because you just, this is what we in mathematics, we got the distributive property. Whatever's in front. In mathematics, we have this rule. The distributive rule. You do the same thing here. Let's test it. How many rows do we need? How many letters do we have? We have 2 letters, P and Q. We're doing this side first. So we need 4 letters or 4 rows. P and Q. true, 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 false, false, true, false, false. So to answer this, what do we need to do first? The parentheses. We have to do the P and Q first. True and true, true. True and false, false, false and true, false, false and false. Again, it's much easier after you finish this class. Do your homework to review your notes. We did this last time. The pipe, it's an and statement. Now we've got the inside done. Now we got to do the negation of it. So the opposite of true is false. True, true, true. So this is the truth table for this side. Again, we only have 2 letters, so we need 4 rows. PQ. True, 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 false. We're doing this side now. What do I have to build first? I have to build the not P. So it's opposite of the P column. So it's false, false, true, true. Then I have to build the what? The not Q. So the opposite of Q. So it's false, true, false, true. I have not P, not Q. So now I could do the statement. Not P or not Q. False or false. False or true. True or false. True or true. And they're equal. Again, you have to memorize those operations. We have the and, or, the if then, and the biconditional.
Going to Y, the last row.
Look at your notes. What does this symbol here mean?
That is,
No, this symbol here in the middle. This symbol here.
that is 4.
Okay, what does the or statement mean? What picture we use to define the or statement? See, that's why you have to look at your notes. That's what I'm saying, is if you don't do it, you forgot everything from last class. It's an or statement. For the or statement, we use the 2 pipes.
Yes.
Because I could pour it in here, or I could pour it in here and see what happens. If either of them are open, then the water comes out. If either are true, the whole thing's true. So let's look at now the other statement. The P or Q. So what do you think this one becomes? what's on this side of the equal sign? Very good. Because we distributed, we changed every element. We have not P, not or becomes and not Q. Those are called De Morgan's laws. We actually did those last chapter. Set A and set B, the negation of it. Equals the negation of A union the negation of B. So De Morgan's laws works for both sets and statements. It actually defines our order of distributivity in mathematics. All right. What do y'all think? That's pretty much the majority of chapter 3, up to 3.6. See, taking pictures is not going to help you. You're not helping yourself there. Writing them down, it's called muscle memory. Negations, De Morgan's laws, arguments and truth tables, arguments and Euler's diagrams. Yeah, we'll do that next week and we'll finish up the chapter. And then, if I'm not mistaken, then we get pretty close to jumping into the other class. I think we have one more in 1332. Then we jump to two classes in 0317. And then we come back to here. And however far we get at the end of the semester, as far as we get. In other words, if we don't finish the semester, don't worry about it. It's wherever we finish in lecturing, I'll cut off all the assignments there and delete the rest.
Are you gonna have to, we're gonna have to take like the final test at the end of the semester? Like,
Haven't decided that yet. I'm waiting to see that because I'm trying to see on how many people are taking the class seriously and who's doing their own work versus